Good afternoon, students. So far, we have learned about what is meant by linear programming problem and how to get the solution through the application of transportation technique. And thereby, we have also learned certain other aspects. Those aspects are what are the characteristics of a transportation problem, in the sense that LPP, whatever the given linear programming problem is there, whether it can be solved by the transportation technique or not. If that linear programming problem has a particular or peculiar nature, like from to, source, user, from present, future, like that, then this is like that it can be solved by the transportation technique. And what this transportation technique consists of, we have studied. Okay, today what I will do is I will take a typical problem so that we can more precisely know how exactly we can apply the transportation technique. Before going for explaining the particular problem, let me see how the transportation technique or the method works by putting it in the form of a flow chart. This is the flow chart for transportation technique. So it will naturally, this is the start. And the next one is we should set it up. The problem, whatever is given in the descriptive way, it has to be set up as a transportation problem. Next one, we should find out the basic feasible solution. BFS, we know that there are 5 ways of BF, the basic feasible solutions. There are 5 methods. Out of those 5 methods, the best method is the WAM method, and how the WAM method works and other things we know already. After this one, we need to find out whether the solution, basic feasible solution, is optimal or not. Whether the solution BFS is optimal or not. Optimal, yes. Then the iteration stops. And the current solution is the best solution. If it is not optimal, then revise the solution. After revision, again it should be tested for optimality, and the same thing continues. Optimality is checked by what is called as Modi method. What is Modi method and other things have been discussed in the previous class. Again, to emphasize more on that one, let me take up a typical problem and then see how again these things can be applied, so that we can consolidate regarding the application of transportation technique. Okay, let us take an example. Let us see that there is a company which has got 2 manufacturing plants, namely A and B. It manufactures certain item, and in the cities A and B, and there are 4 showrooms. in different cities. Let those cities be W, X, Y, and Z. These are the plants, these are the showrooms. Let us say that the maximum capacity of the plant A is 200 units, and maximum the plant B can produce is around 100 units. Let us say that the requirement for the showroom W is 75. Requirement for the showroom at X city is 100 units, Y city 100 units, and Z city the requirement is 30. Okay. Now try to observe carefully about this one. Whatever the values here, it is going to be given are the profit. If that item is manufactured in plant A and sold through the showroom W, the company realizes the profit of 90 rupees per unit. If it is manufactured in plant A and if it is sold through the showroom X, it will realize a profit of 90 rupees. And if it is manufactured in plant A and sold through the showroom Y, it gets a profit of 100. This is 110 rupees. Similarly, if it is manufactured in plant B and sold through W 50, 70 rupees it will make per unit if it is sold through like this, and let us say 130 rupees profit. These are the profit the company is going to make. And if it is manufactured in plant B and sold to the showroom Z, it realizes a profit of 85. Okay, these are the conditions. What is required now? What is the objective? If the conditions are like this, because here there are 4 showrooms, their maximum capacities are given. These are the 2 plants. The maximum capacity is 200, 100 respectively, and here the maximum demand is going to be so much. Not only maximum, it is the exact requirement as well. Now the solution, finding the solution means what? How much is to be manufactured in plant A? Of course, it is known that 200 are to be manufactured. Only thing is, how much is to be sold from plant A to different showrooms, and how much is to be sold through the showrooms W, X, Y, Z, whatever is manufactured in plant B, so that in total the company should maximize its profit. Try to understand what are the things given over here. They will represent the profit per unit. It is manufacturing certain item. The item is same. Let us say it is TV or whatever it is. Here also it is so many TVs, here also so many TVs. Whatever it is. But here it gives the profit. In the previous example, we have seen that it was the cost. Cost is to be minimized. But the profit, what is to be done? Profit is to be maximized. Okay. That is, once that is understood, now what has happened? Now first I told you, we have to set it up as a transportation matrix. Transportation matrix in the sense, we need to find out this units compatibility. The units are expressed in the same unit, the things are expressed in the same units, hence unit whatever are here by -1, and then proceed ahead. But it appears to be illogical for an engineer or a practical person like an engineer. So what is the next best way out? The next best way out is create the mirror image of these things. So that if you look at it, maximum profit is here. I should allocate maximum to that particular cell only. How it is possible? By using this method. So if we observe that one, okay, one will say that it is a matrix. So you, from the largest value, you subtract the corresponding values. So by doing that one, I am going to create the next matrix. Let me see that one. Okay. So what I will do is, which is maximum here? The maximum value is 130. This 130 is to be subtracted from each and every cell. From 130 maximum value, corresponding values are to be subtracted. Okay, this is A, this is B, this is F, W, X, Y, Z. Okay, this is 200, 100, 5, 75, 100, 100, 30. Now I am subtracting from 130. 130 minus 90, this is going to be 40. 130, 90, 40, 30, 20, 80, 90, 60, 80 plus 50, 130 minus 50, 80, 60. This is 0, 85, 15, 45. This one is 130 minus 0. This is 130, 130, 130, like that. So what I have done is, I have created the mirror image of the actual thing. That means if now I apply the WAM method or least cost method or whatever it is, northwest corner rule or whatever it is, I should apply it to the least cost. Which is the least cost here? Least value? Least value is 0. In reality is what? It is 130. Next least value is how much? Next least value is 20. You can see that. Next to 130, this is 110. That is how it works. So now it is available in the standard form. So if we look at the flow chart, now first thing we started and we have put it in the standard form, set it in the standard matrix form. That is what we have done. Next one is, we need to find out the basic feasible solution. As I told you, the best thing is the WAM method. We will try to apply that WAM method. And in the process, we are going to learn again. So it will become the recapitulation of the previous things. Okay, what is to be done in case of WAM method? We have to find out the penalties. Okay, we'll go row wise. Now, what is going to happen? Least and next least difference. The 20, 30, that means difference is 10. Here the difference is 45. 45 minus 0. Here difference you see, 130, 130, 130, 130, it is 0. Here it is 40, 80, 40. This is 40. This is 60, 40, 20. This is 0, 30, 30. And this one is 45, 20, 25. So which is the highest penalty? That means I need to consider this second row. These things are to be chosen, and in this second row I will select, and whichever is the least, there I will allocate maximum. So this maximum, how much I can allocate here? 100. So this thing goes to 0, this is 0, and I cannot, this column is not available for me, as well as this row. Okay, this is what has happened. Now what I will do again, because this one is taken out now. Now again for this one I will find out. The difference between this one is 40 and 20, this is 20. This row it is not available, then again this is 0. This is 40, 130, it is 90. This 40, 130, again 90. I cannot take up this one. Now I will take up 130 and 20, 110. Okay. So which is maximum here? Maximum is 110. So which is the least here? 20. How much I can allocate? I can at the most I can allocate 30. So this will become 170, and this column will not be available for allocation. So again I will find out the difference here. This is 0. This difference is 0. This difference is 90. This difference is 90. Of course, I cannot do anything with respect to this one. Let me select this one. The maximum this thing available over here. That is what I'm going to select over here. Because now you could have asked me here, because here also 90, here also 90. Which one I should select? Arbitrarily we can select, but the best thing is whichever is maximum possible allocation, that I will select first. Here maximum allocation possible is 100 here, because this is 100, there it is 170. But here it is 75 and 170. That is why first I will give preference to this particular column, and out of this thing, which is the least? Least is this. So I can allocate 100 over here. So this will become 70. This will become 0. Hence, this is not available for allocation. Only these two are left. So to balance that one, this will become 70 and this will become 5. Okay, friends, now you just observe. 70 plus 100 plus 30, 200. This is 100, 100. This is 5, 5. 70 plus 5, 75. 100, 100, 30. Perfectly matched. But is it optimal? What is going to be the total cost or total profit we need to find out? Because if I multiply this with respect to this, it will not give me the real profit value. The real profit value is 90. Because we have created the rear mirror image of this one. So when actually you want to find out, this is not the real profit. It is the virtual profit. So real profit is this. So if you want to calculate this one, we need to calculate it as in the following way. Okay, 90 into 70 plus 90 into 100 plus 130 into, here I can take 110 into 30. Next one is 130 into 100, and next one is 5 into 0. 1, 2, 3, 4, 5. Now you can see that there are 5 allocation, 1, 2, 3, 4, 5. So total profit is, right? If we are going to add these things, it works out to be 31,600 rupees. Don't multiply this one. So it is going to give us the erroneous result. Okay, never do that one. That works out to be some 19,900 or whatever it is, 8,050. It might work out to be 8,050. That is not the real thing. The real profit is 31,600. If it is understood, next what is to be done? We have found out the feasible solution, but it is number of allocations are how much? This is a basic feasible solution, because number of allocations are not more than, m is here 3, not 2. M is 3, 4 minus 1. This should be, I should have 6. It should not be more than 6. I have got 5. Hence it is a basic feasible solution. But it is a degenerate basic feasible solution. If it is degenerate basic feasible solution, then I cannot test it for optimality. Even though this might be optimal solution, bear in your mind, even though the given solution is optimal, but I cannot check it for optimality. If it is to be checked to be for optimality, if the Moody method has to be used, then number of allocations should be exactly equal to m plus n minus 1, and in this case it should be exactly 6, but here we have got 5. What this one? So that means it is degenerate case. That is what in the initial feasible solution itself we have got degeneracy. Now how to get over this degeneracy? If this occurs, what is going to happen? We are unable to find out the Lagrange's coefficients, namely ui and vj values. If we cannot find out ui and vj values, that means implicit cost, then we cannot find out the net evaluation, that is the difference between Cij and ui plus vj values. We cannot find out. So hence optimality testing cannot be done. So only way out is, now I need to make some allocation so that it is very small allocation. Addition of that one or some adding that much amount or subtracting that much amount, it should not cause any difference. For example, in an ocean, even if I take one bottle of water, what is this thing remaining? It doesn't, if I add one bottle of water, it is not going to affect at all. So we are going to consider one small amount which is infinitely small, that is epsilon. That is what we are going to do it. And then go ahead with these things. So now allocations I will write and then see. So I have to cover it very fast. Let me see whether I am able to complete. Maybe within given hour. I may have to rush through. Okay, logically it appears to be the proper allocation, because wherever the maximum profit is there, we are getting the maximum allocation. Okay, this is what we have done it. Now the number of allocations are 5, but I have to make it 6. So I am going to fix or allocate some epsilon quantity to one of the empty shells. Then which empty shell is to be considered? That is what we need to see. Which empty shell is to be considered? Can I consider this empty shell? But if you look at it, one way is, it has got the highest cost, 130. That's 130 this one. The another thing is, if I consider this one, if I add this one, it is going to make it a closed loop circuit. See, for example, here. So it will not be in independent position. So two things are to be met. One is, it should be in independent position. Independent position in the sense we should not be able to form the closed loop. So supposing that even if it were some value 0, I could not have allocated it over here. Try to understand that. Because it will form a closed loop, so it is not available. However, in this case, apart from this one, it has got the maximum cost. First, what we'll see is the unfilled shells, or the empty shells, wherein the cost is minimum, that we have to see here. The cost is minimum, this one. Then second one is, when I allocate some epsilon quantity, it should not be able to form the closed loop. That means it should be in independent position. So if I allocate this one epsilon here, okay, this is the least cost, one thing, that condition is met. Second one is, by doing this one, I am unable to find any closed loop. That is what I gave you an example. If it were lesser than 30, say for example, if it were 20, okay, even then I could not have allocated because then it would have formed the closed loop like this. Okay, if that is understood, fine. This is S long. So now how many allocations are there? There are 1, 2, 3, 4, 5, 6. Adding F long, say for example, adding F long to this 100 means 100 plus F long is 100 only. Okay, adding this F long to 70, just the subtracting, 70 minus F long is how much? 70 only. So these F long, how many F longs are to be added? So many F long till it makes M plus N minus 1, that figure. Here there is only one shot, and if there were only 4 allocations, then I would have made epsilon 1 and epsilon 2 like that. Okay, that further reading I'll leave it to you because of the paucity of the time. Okay, now having done this one, now it is possible for us to find out the Lagrangian coefficients or the row coefficients and the column coefficients, and hence we are able to test its optimality. So now having done this one, this is U1, U2, U3, V1, V2, V3, V4. Now I told you one of the values I have to make it 0. Which one will make it 0? Wherever the maximum allocations are there. Fortunately, the maximum allocations are there for U1, all the 4. So U1 I'll make it 0. So immediately V1 will become 40. So how much simple it is, you just see. This will also become 40, this will become 30, this will become 20. Well, I need to find out only these 2 values now. Okay, this one is allocated cell, this is 30, so this has to be how much? It has to be minus 30 because minus 30 plus 30 should make it 0. Now, how much it has to be because already it is 40 and this is 130, that means it has to be plus 90. This is minus 30 and this is plus 90. 90 plus 40, it will make 130. Try to understand. Okay, don't say that here I am going to allocate this one 100 plus F long. That means it is more than 305. No, not like that. Okay, try to understand this because 100, 100, 200, 230 plus 70. Yes, then this one is 5. 305 plus F long. That means it is almost F long. Don't enter that impression. Okay, fine. Now this is what I have found out. Now what is to be done? I need to find out Ui plus Vj values for the empty shells. Even if I found out for non-empty shell, it is going to work out to be 40 only. Here it is 40, 40, 30, 20, and difference if you take 0, here also 0, there is no point in finding out that. So empty shells I need to find out. So minus 30 plus 40, this is going to be 10. Is it not? 40 minus 30, 10. 60 minus, sorry, the 60, 40 minus 30, again it is going to be 10. 20 minus 30 minus 10. Here if I look at it, 90, 40, 130. 90, 30, 120. 90, 20, 110. If I find the difference over here, 80 minus 10, 20, 60 minus 10, 50, 45 minus of minus 10, 55. Here 130 minus 130, 0. 130 minus 120, 10. 130 minus 110, 20. And of course, these values will become 0, 0, 0 elsewhere. So you can see that the optimal condition is reached because these differences, they are greater than or equal to 0. All are greater than or equal to 0, but you need to be particular about the empty shells. Here what we can see that in an empty shell there is a 0 allocation, so the 0 value. Yes, it is optimum value, no doubt about it. Whatever you do, we cannot get profit than 31,600 rupees. Whatever you do, it cannot be more than this. Okay? But this zero, what does it suggest? It is not the unique solution. There are multiple solutions, multiple optimal solutions. That means one of the solutions is this. Another solution, I can get you the same value, 31,600. How do I do it? Instead of this one, because 130 here, 130 here, instead of 5, I will make this one as allocation here 5. And this one, because totally it should not exceed 100 or whatever it is given over here, it should not exceed that 100, so it has to be made as 95. 95 plus 5, 100, because the requirement was 100 here. Okay, now what is the requirement? The total, this thing availability, this has to be 200. That means there is no other way, but it has to be made as 75. Because whether I can reduce here, increase here, and reduce here and increase here, it doesn't make any difference. The total quantity is going to remain same. Again, this will become 75, this will become 100, 100, 30, this is 200, this is 100, this is 5. Because this is another solution compared to the other one. If you calculate the value, you are going to get it as 31,600 rupees only. This is what we say that it is multiple optimal solution. So it has got its own advantage because it has got the flexibility. Okay? So this example, it is a better example what I feel for the simple reason that, see, it has got how many of these things? One is it is unbalanced. Another thing is profit, it is a maximization problem. Third one is feasible solution is degenerated one. And the fourth one is it will talk about the multiplicability also. In the previous example, whatever I had taken, it was the unique solution. That is why I had emphasized that. It was a unique solution. And there was no degeneracy when we found out the initial feasible solution. And to begin with itself, it was a minimization problem. Okay, my dear students, these are the things how one can apply and handle these situations. Is it followed? If there are any doubts, you can ask me now itself. Because I am going to wind up this particular chapter. Okay? So this is how these things are to be done. In some cases, what is going to happen is they might give, so this is the plant. Okay? In construction itself, when we are going to construct, they might give the plant, their transportation cost also they will give, and they will give the production cost for each plant. And in addition to that one, maybe when it is being sold through the distribution centers, there in the distribution centers, they might incur certain cost, that will also be given. So it is some of the thing is what you need to understand what needs to be done, total cost or whether total profit, because which is to be found out, which would have been mentioned in the given problem itself. So friends, first thing is what? You need to understand that, is it belong to, first thing is, does it belong to linear programming problem? Given problem is a linear programming problem. Then next one is, it needs to be formulated. It might be formulated in the sense because it is given in the descriptive form, it needs to be expressed in mathematical form. Expressing in mathematical form means what? Expressing it in terms of mathematical equations or expressing in terms of matrix form. So transportation technique, it requires that it should be expressed in matrix form so that it becomes much easier to handle. So if it is to be expressed in matrix form, then these are the things. What are the things? The availability and the requirement are to be expressed in the same unit. The body of the matrix. it should give unit profit or unit cost only. Those are the requirements. Then this method is to be applied. Of course, we need to see that it should be balanced. Next, then we have to check it for whether it is maximization or minimization. If it were maximization, convert it into a minimization problem like this and try to find out the solution for that. Then again, when you are going to put it in the form of the values, it should not be multiplied 75 with 40. No, it's 75 with 90, 95 with 40. Okay, it should be done like that. Okay, that is the crux of this one. And now let us see if it were to be solved by simplex method, what would have happened? Because now I have expressed it in matrix form. Because I am going to continue this discussion for the simple reason that I have got still more some 10 minutes time. Okay, for that reason, I want to compare, because then only you are going to realize how the transportation method technique is much better than simplex method. Okay. For simplex method, I'll go to the original problem. If you have understood, so I am going to wipe up this one. Okay, this was our original problem. Now, if I want to express it in a mathematical form or the equation forms, what I will do, first one is, what is the objective? The objective here is to maximize these things. These are the profit, try to understand. So, maximize these values. That means maximize Z. So, this is what Cij value, that means this is in general C11 into whatever I am going to get, this one is Xij value, that means C11 into X11 plus C12 into X12 plus C13 into X13 plus C14 into X14 plus C21 into X21 plus C22 into X22 plus C23 into X23 plus C24 into X24. All these values have been considered. These are nothing but Cij values, and correspondingly this whatever gets allocated, these things are to be found out. These are the Xij values. This is the objective. Objective is maximize this. Subject to consider these Xij values. Xij values are how many? This one X11 plus X12 plus X13 plus X12 should be exactly equal to 200. This is what? X21 plus X22 plus X23 plus X24 is equal to 100. And now column wise, I need to find out. This is X11 plus X21 should be equal to 75. X12 plus X22 should be equal to 100. X13 plus X23 should be equal to 100. And X14 plus X24 is equal to 30. Got this one? How many equations are there? 2 plus 4, 6 equations. And how many variables are there? That is m plus n. M is 2, n is 4. 6 equations. How many variables? M into n, 2 into 4. There are 8 variables. Try to understand this. But really, if I want to solve it by simplex method, if it is equation 2, yes, okay, fine. But if it is to be solved by simplex method, I need to add not neither the slack or surplus variable, but I need to add the artificial variable because it is equal to type. So each one of them, it is going to get one artificial variable. A1, A2, A3, A4, A5, A6. So the total variables will become not 8. They are going to become 14. 8 plus 6. 14 variables and 6 equations. Again here objective. Now I have to make this one minus MA1, minus MA2, minus MA3, minus MA4, minus MA5, minus MA6. This is the thing, and it is to be solved by a simplex method. You just see what is going to be the complexity of that one. Hence, under these circumstances, it is of equal to and units are same. The best way out is to go for transportation technique. Doesn't mean that it cannot be solved by a simplex method. Yes, anything can be solved by a simplex method. That is the most general method. But if these things from equation to equation, the units vary, then I cannot solve it by transportation technique. So the most general technique is the simplex method. This is the transportation technique. And the next extension of this one, sometimes what happens? It fails. Some other, it fails, it will become most lengthy method, certain thing. That I will try to give the introduction about the assignment type of problem. Okay. Now we have concluded about the transportation problem. Now we will think about the assignment type of problem. That I will just give the brief introduction about that one. So that will tell us what is the superiority of or when we should go for assignment type of problem or that solution method. For example, let us say that there are 4 jobs and 4 people, and they have got a different efficiency to work with it. Because we got, say for example, we have got exactly 4 jobs, 1, 2, 3, 4, and there are 4 people, A, B, C, D. Only one job can be assigned to one person. No 2 jobs can be assigned to one person. Or not 2 persons can be assigned to one job. One job to each person. That is the requirement here. That means here availability is 1 for each of these things. And requirement is also same 1, 1, 1, 1. That means necessarily if it is a square matrix and the requirement or the availability for each row is 1 and the requirement for each column is 1, then this is the candidate for solving it by assignment technique, which is also called as Hungarian technique. Here also it is a minimization, cost minimization only. So the body of matrix, it will give us what? The values. Those are the costs associated. If it is a profit, again, when it is to be done, it is a minimization, so it needs to be converted into minimization only, like what we did this thing. Let us say that is this 4, cost 3, 5, 2, something I am putting 8, 5, 3, 7, 5, 0, 2. This is 1, 2, 3, 4. So we need to find out which job is to be allocated to which person, but one job to each person. So in that case, the total cost is to be minimized. So what is going to happen? Here at the most, how many allocations will be there? At the most, it is going to have only 4 allocations. Try to understand. Now, the number of variables are how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. There are 16 variables. But how many equations are to be given? Or how many allocations are we are going to have? At the most, I can have only 4 allocations. But if it is to be solved by the transportation techniques, how many allocations I will be getting? 4 plus 4, 8 minus 1. I need to have 7 allocations to test it for optimality. But when I solve this one, I can get only 4 allocations. That means it is completely degenerated form of transportation problem. It is completely degenerated. Only 4. But we want exactly here 7 allocations. So F long 1, F long 2, F long 3, these are to be added. Then it is to be done. It should be calculated like this. So in that case, they started thinking, is it under these circumstances, is it easier to go for another method? They found out the solution, yes. What they call it as Hungarian method. So this Hungarian method can be used for assignment type of problem. What is assignment problem? I have discussed. So in future we'll discuss about this assignment problem. But it is the initial introduction I could give regarding the assignment problem. Okay. So in the subsequent class, let us see. Okay, I'm going to stop it over here. So what you need to understand is you try to draw the flow chart for this one. I have already explained you regarding the transportation method. And again, you try to write down the steps of WAM method, and then again write down the steps for Modi method. That way you can understand. That way you can understand the problem in much, much better way. Okay? Hope we had some fruitful classes regarding this thing. And I am going to stop at this point. Okay? Thank you.